You know, the biggest headache with AI coding tools right now, for
Right.
me, it's this thing I call the brain in a box problem.
Brain in a box. I like that. That's a very vivid way to put it.
Well, just think about it. You've got this incredible AI brain just sitting there in a chat window, right?
Hmm.
It knows Python, it knows Rust, it knows how to refactor an entire database schema, but your code, your terminal, your actual work, the body is somewhere else.
And they're not really connected.
Yeah.
It's the classic fragmentation issue. The brain can't actually see what the hands are doing.
Exactly. So you're copy pasting code back and forth, or the AI is just hallucinating a file structure because it's guessing based on something you pasted 20 minutes ago. It feels,
Disjointed. It feels clunky.
yes, disjointed. It's like trying to build a Lego set while someone shouts instructions from another room. But that actually brings us to why we're here today. We're looking at a big technical release from OpenAI that just dropped on February 17th, 2026. It's from a post by their engineer, Celia Chen, and it details the architecture for the Codex App Server.
And this is not just some product update. It's a full-on architecture reveal. They're basically showing us how they finally managed to decouple that Codex brain.
From the body.
From the body, exactly. Whether that body is VS Code, JetBrains, a web browser, whatever. And all using a single unified protocol.
So the mission for this deep dive is to really tear that architecture apart. We're not just, skimming a press release.
No, we're getting into the weeds.
We're going to look at the primitives they invented,
Yeah.
why they rejected the industry standard model context protocol, which is a bit of a spicy topic, and what all this means for the future of dev tools.
It's essentially a write once, run anywhere philosophy, but for an AI agent. And the engineering behind it is surprisingly elegant.
Okay, so let's start with the core challenge. Why was this so hard? I mean, we've had client-server models for decades. I send a request, the server sends a response. Why couldn't they just use that?
Because that standard request response model, think of like basic HTTP, it's fundamentally stateless.
Right, transactional.
Exactly.
Yeah.
You ask for a web page, the server gives you the web page, end of story. The server doesn't remember or care what you do next.
It's a vending machine. I put a coin in, I get a soda out.
Perfect analogy.
Right.
But a coding agent isn't a vending machine. It's more like hiring a contractor to fix your roof. You don't just say fix it and instantly get a done signal.
No, of course not. It's a whole process. They
Yeah.
got to inspect the damage, go buy supplies, come back, start hammering.
They might even ask you a question halfway through, right? About the shingles or something. It's a sequence.
Right.
And OpenAI realized that a single user request like refactor this module kicks off this messy unfolding chain of events. The agent has to read code, it has to plan, write, create a diff, maybe run a test.
And if you try to cram that whole timeline into a simple, I sent a message, I got a message box, the user experience just breaks. You're left staring at a spinning wheel, wondering if the thing is dead or just thinking really hard.
That's the problem. The client, your VS Code window, it needs a way to represent that process faithfully. It needs to know that the agent is specifically running a grep command or generating a diff, not just thinking.
So to solve this state problem, they didn't just tweak HTTP, they invented whole new conversation primitives.
Correct. And there are three pillars to this whole thing: items, turns, and threads.
Let's drill into those because this is really the vocabulary of the new system. So start with the item. What is that?
The item is the item, the atomic unit of the conversation. Now, in a normal chat, an item is just a text bubble. But here, an item is polymorphic.
Polymorphic? What do you mean? It can take different shapes.
Yes, an item could be a message from you, but it could also be a tool execution, like the agent running a command. It could be a request for your approval. Or, and this is so important, it could be a code diff.
Okay, that's really interesting. So a diff, the actual visual red and green change in the code, is treated as a first-class citizen in the protocol, just like a plain text message.
Exactly. And these items, they have a life cycle. They're not static. An item begins in a started state. Then it can receive what they call delta events.
Like streaming updates.
Precisely. Think about watching the agent write code. You don't want to wait 5 seconds and then have a huge block of text just slam onto your screen.
No, you want to see it typing.
You want to see it typing character by character. Those are the delta events streaming into that single item. And then finally, it hits the completed state.
Got it. That gives the UI incredible control. It knows exactly when to show a spinner, when to animate the typing. It stops the whole thing from feeling clunky.
Yeah.
Okay, so that's The atom, the item, what's the molecule? The turn.
The turn is basically a grouping mechanism. It goes back to our contractor analogy.
Yeah.
If you tell the agent to fix the bug, the agent might generate, I don't know, 10 different items to get that done.
Reading a file, thinking, writing code, running Git test.
Yeah, all that stuff. It's a lot of noise. A turn captures that entire sequence and links all those little machine actions back to your one single human request.
That's actually a huge usability feature. I've used tools where the history just becomes this chaotic wall of...
Just a fire hose of events.
Yeah. I read the file, I thought about the file, I wrote the code, and I'm just scrolling forever trying to find where I actually asked my question.
A turn lets the UI just collapse all of that it can show. User asked to fix bug, and then all the agent's internal steps are just tucked away inside. It keeps the history clean.
And then finally we have the thread, which I'm guessing is just the chat session itself.
It is, but they call it a durable container. And that word durable is key. The thread handles creation, forking, and crucially, resumption.
Why is resumption such a big deal here?
Because developers move around. Maybe you're on a train and the Wi-Fi drops. Maybe you close your laptop to go to a meeting. In a normal stateless connection, you'd lose all that context.
Ugh, that's the worst. You come back and the bot has total amnesia. Who are you? What are we doing?
Right, but with this thread architecture, the entire event history is persistent. So if your VS Code window disconnects, the brain on the server remembers exactly where it was. When you reconnect, you just sync back up to the thread and the whole state is restored.
So we have the structure, items or actions, turns group them, threads save the history. But how is this data actually moving? You said it wasn't HTTP?
No, they went kind of old school. They're using JSON RPC.
Remote procedure calls. Wow, okay. That's a classic.
It is, and specifically, they are streaming it as JSON. That's JSON lines over Studio.
Studio. You mean standard input-output. Like
Right.
literally just piping text between processes in a terminal.
The very same.
That feels almost primitive. Why not WebSockets or gRPC? Why use something that feels like it belongs in the 90s?
It's all about where this thing lives. The main use case is a local editor, like VS Code on your machine. Studio is incredibly fast, has zero network overhead when it's local, and it's universal. Every language knows how to read and write to standard out.
That's a fair point. If it works, it works.
Plus, they built it to be backward compatible. An older client can talk to a newer server without just crashing, which is obviously essential when you have millions of users on different versions of VS Code.
Now, in the protocol specs, there's a mechanism that kind of flips the whole client-server relationship on its head. Usually, I, the client, ask the server for something. But here, the server can ask me for something.
Ah, yes, the server-initiated request. And this is absolutely vital for safety.
Walk me through a scenario where that happens. Because, yeah, servers don't usually ask questions.
Okay, so let's say the agent the server decides the best way to fix your bug is to run a shell command. Maybe it thinks I need to delete this temp directory, so it queues up an arm-arf command.
Whoa. Okay, yeah. I definitely want to sign off on that before it just happens. I don't want some AI nuking my hard drive because it thought it was being helpful.
Exactly. In a normal setup, the server might just do it, or it would struggle to interrupt its own workflow to ask you. Here, the server sends a request to the client. The current turn actually pauses.
It freezes the state.
It freezes the whole workflow. The UI on the client pops up a little modal. The agent wants to run this command, allow or deny. The agent literally cannot proceed. It's blocked at the protocol level until you send back an answer.
That is a true human in the loop by design. It's not just a UI trick. The actual process is suspended, waiting for my permission.
Correct, and that pause functionality is baked right into the turn primitive. This is one of the main reasons they couldn't just use a generic protocol. You need that level of state management.
This actually leads us perfectly into maybe the biggest controversy in this whole release, the why not MCP debate.
Ah, yes, the Model Context Protocol.
For anyone listening who isn't glued to GitHub, MCP is like huge right now. It's backed by Anthropic, a bunch of others. It's meant to be the USB-C of AI, a standard way to connect LLMs to data.
Right. If you want your AI to talk to Google Drive or Slack, you use MCP. It's kind of the industry darling at the moment.
So OpenAI admits in their post that they tried to use it for Codex. They built a prototype, but then they threw it out. Why? If everyone else is converging on MCP, why would you go custom?
It really comes down to the difference between, let's say, using a tool and inhabiting a session.
Unpack that for me.
MCP is, like the name says, a context protocol. It is fantastic at tool use. Here's a hammer, go hit that nail. Here's a database, go fetch me that row. It's very transactional.
Go get this info and come back.
Exactly.
Yeah.
But OpenAI found it was too tool-oriented for an IDE. An integrated development environment isn't just a bag of tools, it's a continuous, immersive session.
So MCP was too rigid, it couldn't handle the flow?
It struggled with the rich session semantics we just talked about. Specifically, streaming those code diffs line by line, handling those complex pause and wait approval flows, and maintaining that deep thread persistence.
I remember Celia Chen's note was pretty specific. She said maintaining MCP semantics in an environment like VS Code proved difficult.
Which is, polite engineering speak for it was a nightmare to implement and it didn't really work.
So they weren't just trying to be difficult or lock people in. They felt they actually needed a higher fidelity protocol than the standard allowed.
That's the argument. And to be fair, they do still support MCP for simpler things. But for that deep integration where the AI feels like it lives inside your editor, they needed their custom app server.
It's sort of like the difference between using a website on your phone's browser versus using the native app.
That is a perfect analogy. The app server is their native app approach. MCP is more like the mobile web approach. Both work, but the fidelity is totally different.
Okay, so we've got the architecture, we've got the protocol. Let's talk deployment. The promise was write once, run anywhere. How does this one server run on my laptop and inside a locked-down web browser?
This is where the design gets really clever. They have three main deployment patterns. The first is what we've been talking about, local clients.
Right, the VS Code extension or the desktop app.
In that case, the app you install actually bundles a binary of the app server. When you open VS Code, it just launches that server as a child process in the background. They talk over that Studio channel.
Simple enough. It's running right there on my machine.
But then you have decoupled clients. Think about something like Xcode.
Apple's IDE.
Right. Apple releases Xcode on its own schedule. OpenAI updates Codex weekly. They can't wait for Apple to ship a new version of Xcode just to push an update to the AI logic.
That would be a nightmare. You'd be stuck with AI models that are 6 months old.
So in this pattern, the client Xcode stays the same. But it points to a separate, newer app server binary that can be updated independently. It decouples their release cycles.
Very smart. But the third one, the web runtime, is the one that kind of bends my brain a little.
Yeah, the browser it's a hostile environment for this kind of thing.
Right. A browser can't just launch a child process binary. Chrome isn't going to let you just execute code on my machine.
Of course not. So for the web, they move the architecture to the cloud. When you use Codex in a browser, a worker in the cloud provisions a container and launches the app server inside that container.
So the server is actually running on a real server.
Yes. And then, instead of Studio, it just communicates with your browser using HTTP and server-side events, or SSE.
And here's the key. Does the architecture itself change? The logic?
No. And that's the beauty of it. The turn and item structure, the whole logic of the conversation, it all stays exactly the same. The only thing that swaps out is the transport layer.
So my browser UI stays super lightweight. It's just getting events. Here's some text, render this diff, while all the heavy lifting happens in that cloud container.
It creates what you could call a chameleon architecture. It just adapts to its environment, local, decoupled, or cloud, without ever rewriting the core agent logic.
This all leads us to the broader industry picture. We can't talk protocols without talking about the standardization wars, because OpenAI isn't the only one trying to solve this.
No, not at all. There is a major contender out there called ACP, the Agent Client Protocol.
And this one's backed by some heavy hitters too, right?
It was initiated by Zed Industries, the people who make the Zed editor.
Yeah.
And it's supported by JetBrains.
JetBrains is huge. IntelliJ, PyCharm. If they're backing ACP, that's a serious project. So what's their philosophy?
ECP wants to be the universal standard. Think of it like USB. They want a single protocol that can connect any agent to any editor.
Whereas the Codex App Server is specifically designed to make the Codex agent work its best.
Exactly. The analogy everyone keeps using is LSP, the language server protocol.
Refresh my memory on LSP.
Okay, so maybe 10 years ago, if you wanted to build, say, a Python plugin for VS Code, you wrote it for VS Code. If you wanted it for Vim, you had to rewrite it completely for Vim. It was a mess.
Total fragmentation.
LSP, standardize that. Now, you just write one Python language server, and you can talk to VS Code, Vim, Sublime, anything. It totally revolutionized developer tools.
And ACP wants to be the LSP for AI agents.
That is the ambition. They want to avoid a future where every AI model needs a custom adapter for every single code editor.
So is OpenAI fighting that? Are they trying to kill the open standard?
It's actually more nuanced. And here's the twist. The Codex CLI is officially listed as compatible with ACP.
Really? So they built their own custom high-fidelity protocol, but they also support the universal standard.
It seems so. Which suggests that OpenAI isn't just trying to build a walled garden for the sake of it. They built the app server because they needed features that didn't exist yet. But they're not slamming the door on interoperability.
It sounds like we're in that messy, early phase of a new technology, like when we had HD DVD and Blu-ray or all the different charging ports before USB-C finally won.
We're still trying to figure out the right abstraction boundaries. We just don't know yet if the industry will settle on one universal standard like ACP, or if the really big, complex models will always need their own custom nervous systems to function at full capacity.
That is the billion-dollar question.
Okay.
So if I'm a developer listening and I want to play with this new architecture, is it all locked away?
No, it's surprisingly open. The source code for the Codex App Server is available in the open source Codex CLI repository on GitHub.
And they provided tools to build with it.
Yep. The documentation includes schema generation tools for TypeScript. So if you're building a tool and you want to connect to Codex with this new protocol, they've made it relatively easy to get started.
Okay, let's wrap this up. What are the big takeaways from this deep dive?
First, the problem. The AI brain was disconnected from the body. And simple request-response protocols were just too dumb to handle the complex, stateful work that coding agents do.
So OpenAI built the Codex App Server. They structured the whole conversation into items, which are the atoms, turns, the logical groups, and threads, the persistent history.
They used a simple, robust transport JSON RPC over STIO, but they added that critical server-initiated request so the human stays in the loop for safety.
And they made that hard choice to reject the popular MCP standard because it was too tool-oriented. It just couldn't handle the immersive, session-based features they needed for a top-tier IDE experience.
And finally, they designed it to be this versatile chameleon that can run locally, decoupled, or in the cloud without changing the core logic.
It really hammers home that AI isn't just about the model. So much of it is the plumbing. You can have the smartest model in the world, but if the protocol drops the connection or can't handle a complex state, the product feels awful.
That's usually the case with great engineering. All the magic happens in the plumbing.
So here's a thought to leave you with. OpenAI built this custom solution because the existing standards weren't rich enough. But as these agents get smarter and more complex, are we just heading toward a world of fragmentation? Will Claude have its own protocol? Will Gemini have its own?
Or will a universal standard like ACP eventually catch up and force everyone to speak the same language?
If history is any guide, proprietary innovation usually leads, and the standards chase from behind. But in the world of AI, behind could mean obsolete in 6 months.
We will be watching very closely to see which way the industry breaks.
Thanks for listening to this deep dive into the Codex App Server.
My pleasure.
We'll catch you on the next one.